Capacitor circuit has two main types. These are the parallel and the series circuit, added with series parallel combination. Parallel is said to be parallel circuit when two or more capacitors are connected across each other. That is, when the two terminals at top are connected together and the two terminals at the bottom are connected together. They are just connected sidewise. Then it is said to be parallel. Whereas in series circuit, when the two or more capacitors are connected in cascaded form, that is, when the tail of the first capacitor is connected to the head of the next capacitor, it is said to be series or serial circuit. Whereas the added circuit here is actually the combination of series parallel. It is said to be series parallel when the two capacitors here, which is in parallel bank, is in series string with the capacitor here. It is said to be series parallel circuit. So, let us have first this first circuit. Let us use here 1 microfarad or 10 microfarad and 10 microfarad here. So, how do you compute for the total capacitance? So, Ct as the total capacitance is equal to C1 plus C2, for there are only two capacitors connected in parallel. Remember that it is opposite to the formula of finding total resistance. When the two resistors are connected together in parallel, the formula is different because we will use RT as the total resistance is equal to R1 times R2 over R1 plus R2. But here is different. So, if the capacitance here is 10 microfarad plus another 10 microfarad for C2 is equal to 20 microfarad. Okay, let us prove. We have here two capacitors which are connected across each other. So, if we are going to measure the capacitance of every capacitor here, using the capacitance meter here, okay, we will set this one to capacitance. Okay, we are now at, what's this? We will use this one here. The range selector should be set to the yellow color. Okay, to the yellow color. Okay, we have here. Then, set this one to micro volt ohms. That is nanofarad. Okay, it goes like this. The capacitance here is, what is that? 9.83. 9.83 microfarad. No? We are just connecting the two test rods to the two terminals of the capacitor. So, it is 9.78 microfarad. This is also here because this is 10 microfarad. But if we are going to measure that, that is 9.87, 9. Let us measure again. 9.78 microfarad. So, that is now the total capacitance, the capacitance of this capacitor, the measured value. Okay, let us connect this one here again. Okay. So, 10 microfarad each. But, when we measure the total capacitance wherein the two capacitors are connected across each other, the result is the capacitance is increased. 19.75 microfarad. So, that is 19.5 microfarad. So, it is verified true. When the two capacitors are connected across each other, there are two 10 microfarads connected in series or connected in parallel. But the formula is different. Ct is equal to C1 plus C2. So we are adding the capacitances. That becomes 20 microfarad. Then, when we measure the total capacitance using the capacitance meter here, the resulting capacitance is 19.5 microfarad. Because actually, the actual capacitance of this using the measured value is, what was that? 9.78 microfarad. That is actually the original capacitance of this capacitor using the capacitance meter. Because the 10 microfarad here is actually the given capacitance printed on the body of this capacitor. Okay. But, when we connect the capacitor in series, we have here, still using the same capacitance or capacitors, 10 microfarad each. Then, what will be the total capacitance? So the formula is different. The formula is different. Ct is equal to C1 times C2 over C1 plus C2. Or you may use Ct is equal to the value capacitance over the number of capacitors. Since there are only two capacitors, so write here 2. Or the number of capacitors. The capacitance of each capacitor is 10 microfarad. Divided by 2 is 5 microfarad. The resulting capacitance now, or the total capacitance for the two capacitors connected in series, is 5 microfarad. So it is lower than the lowest capacitance. Or you may use this formula, but it is more complicated. You can only use this one. This is more applicable if the two capacitor has different capacitances. But since they have the same capacitance, so it is better to use this as the shorthand version. Or you may use the third formula, reciprocal formula. No? 1 over Ct is equal to 1 over C1 plus 1 over C2, or so on and so forth. Because this formula is applicable only when you have two or more capacitors connected in series. But if there are only two, you can use Ct equals C1 times C2 over C1 plus C2. Or if they have the same resistances, it is better to use Ct is equal to capacitance over the number of capacitors. Capacitance 10 microfarad. If there are 3 capacitors connected in series, so you may write here 3. 10 over 3. Okay? Okay. The resulting capacitance now is getting lower. So let us prove. The resulting capacitance here is decreased. Okay? 5.20. So that is 5.26. The capacitance now is getting lower. Actually, it is getting lower. 10 microfarad and 10 microfarad, when they are connected in series, the resulting capacitance is lower. Okay? So as what we have here, it is 5 microfarad. Okay, the resulting measured value here, finding for the total capacitance is 5.27 microfarad. So that is now the resulting total capacitance. So how about the working voltage? The given working voltage here is 16 volts and 16 volts. 10 microfarad with a working voltage of 16 volts. Another 10 microfarad with a working voltage of 16 volts. So the resulting working voltage there is 32 volts. 16 plus 16. 16 volts and 16 volts. When they are connected in series, the resulting working voltage now is 32 volts. But the total capacitance is lower. It becomes 5 microfarad. Whereas here, if this is 16 volts and 16 volts, the resulting working voltage is the same, 16 volts. If this is 25 volts and the other one is 16 volts, with the same capacitances, 10 microfarad and 10 microfarad, 10 microfarad here with a working voltage of 16 volts, and 10 microfarad here with a working voltage of 25 volts. See, the resulting total voltage is 16 volts. It could not be 25 because the maximum voltage that can be applied to the circuit is only 16 volts. Okay, let us try. We have heard the 3 capacitors. The working voltage of this capacitor is actually 35 volts. Then, another capacitor with a working voltage of 25 volts is over here. Then another capacitor with a working voltage of 16 volts. Okay? We will connect them in parallel. So what will be the total? What will be the total working voltage? Connect them across each other. Okay. The 3 capacitors now are connected across each other. Then, okay, let us check very well if there are no errors. Okay. Then, let us try to supply them with, let us say, 31. Okay. What will happen? Okay. See? One of the capacitors explodes. Why? Because the working voltage here is only 16 volts. The applied voltage is 31 volts. The other one is 25 volts. And the last capacitor here, the bigger one, is 35 volts. The 25 volts working voltage of the next capacitor is, the capacitor is getting hotter. No? It is now warm. It is ready to explode. No? Okay. If we try to, it is protruding. The capacitor here is hot. No? It is getting exploding. Later on, this capacitor will be exploded. No? But it will take a longer time. But this capacitor will not explode because the working voltage here is 35 volts. This one here is 25 volts only. The first capacitor that explodes is 16 volts. The applied voltage is 31 volts. So, that will be the result. So, meaning to say, if there are 3 capacitors connected in parallel, this one here is 10 microfarad with a working voltage of 35 volts. This one here is 10 microfarad with a working voltage of 25 volts. This one here is 10 microfarad with a working voltage of 16 volts. the total working voltage actually is 16 volts. Because if it is applied with 35 volts or 25 volts, this capacitor will explode. If it is 35 volts applied voltage, these two capacitor will explode. The first capacitor will explode will be this 10 microfarad 16 volts. But 10 microfarad 25 volts, little by little, it explodes. As the applied voltage is 35 volts. So meaning to say, the working voltage here is very important. At it is the dielectric strength of a capacitor. That is the ability of this capacitor to withstand the applied voltage. So we have here, actually, what is that dielectric strength? Dielectric, actually, the other term is insulator, which is used by these capacitors. What is the dielectric material of this? Electrolyte. 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 This one here, the dielectric material is polystyrene. This is polycarbonate. This is mylar. This is ceramic. Actually, capacitors are named according to the dielectric material being used. So, those are the three characteristics of capacitor. The capacitance, the tolerance, and the working voltage. Okay, that's all, my dear students. Thank you.